Okay, my outstanding friends, once again Roger speaking about nuclear fusion. Now the Department of Energy is going to explain their interpretation of nuclear fusion reactions, and I am going to show you my interpretation. And my interpretation is based on a dipole atomic nucleus and a dipole electron. And I will show you precisely, that is what an electron is. It has a black and a glowy side. The glowy can be red, green, blue, any color, but the black is always the same, and it never changes size. It has almost all the weight. And I show this using an atomic bomb blast. I can show you the two particles. Let's show you those two particles first, and then I'm going to try to explain what fusion and fission and combustion and ignition is all about. It's not fully understood at this moment. Okay, my friends, this should be very interesting. Follow me through on this, because I am going to prove to you, not just speculate, I am going to prove to you that this nuclear fusion that they're doing is basically like burning hydrogen. That's about all it's doing. Because deuterium and tritium are two different types of hydrogen. Let me show you something. Okay, this is a nuclear bomb blast. This proves exactly what I'm saying. CERN's and Fermilab's interpretation of these two particles is correct. But they can separate, and the white always coats the black, because the white wants to get away from each other. So here is what the nuclear bomb looks like. 100% white around a really heavy-duty core of black. When the bomb goes off, what they do is they force everything in and it reconcusses out. All of these white particles go first. They'll burn the house. They don't move it at all. They don't even move it. Then the black comes after and knocks it down. That shows that these are energetic particles with no mass to speak of. And these are massive particles with no energy to speak of other than push. And they have to be shot out of something. Now, this is, again, my model, and it is correct. I can prove this is correct. Now watch. This is atom central. Watch this. This is in very slow motion. The first thing you're going to see is nothing but these glowy particles. That's all it's there. All it does is burn it up, and it's done. No movement. And then, boom, watch this. I got to run in slow motion, that's why. And now it all comes back to the gravity, to the void that it was created. Okay, my outstanding friends, I'm going to go right for the heart of the matter. We've always been told that a proton was just one big solid ball. That's it. That's the smallest there is. And then there was neutrons. They were right in the same area. And then there was electrons, which were just tiny little negatives. A neutron was neutral, didn't have a charge. Proton was a positive charge. In other words, it wanted to attract an electron. Well, why wouldn't it attract it right down to itself? They've never been able to explain this. They've never been able to explain gravity. A lot of things are unexplained, and the nuclear standard model does not work. This is what does work, where everything is a dipole, including electrons. And I can show you this from our experiments, and I can prove it from a nuclear bomb blast, and I will show you what exactly they're doing when they are splitting hydrogen and oxygen and all of these different molecules to create this fission. Now, they're using tritium and deuterium. Now, let me show you exactly what they are doing, and it's not what they're thinking. All right, this is really fabulous, and it's very simple. This is Alex Smith, and he's showing a hydrogen-oxygen balloon explosion. Now, hydrogen-oxygen is going to be in the yellow balloon. Here he's got other gases, I'm not sure what, but they are also somewhat explosive. I think they're hydrogen and other things, but watch.
I never ignited 4 balloons at once. We'll just see what happens.
Watch, he's going to light these off.
No, this is the Delta H.
Now, I'm not sure what gases he's got, but I think he's got hydrogen in all of these. I see H's in everywhere. And I don't know if that's exactly what he's blowing off here or not, but they do explode. Now listen, watch. This always excites him. All right, let's think about what he just did. What's the big deal? He had gases in a balloon. He hit it with a little tiny flame. I mean, the tiniest little bit. And as soon as he touched it, boom, they blew up. And they almost instantaneously combusted. Now let's see what happens when he has raw hydrogen with oxygen. And this is the yellow one. And he's going to tell the kids to keep their mouth open.
How it sounded compared to the sound you would hear.
I think he either just told them or he will tell them, keep your mouth open so your eardrums don't explode. And they all think it's funny. He's putting H2 and O2. Those are the two gases together. And what will he end up with is H2O and a lot of explosiveness. And what is the explosiveness made out of? That's the key. If he's just got protons in there, which are hydrogens and oxygens, where are we getting all this big combustion and big, because you hear it, it's combustive. Listen to this.
If that sound was too loud for you, keep your mouth open, because then the pressure in your mouth will outside you.
See, they think it's funny. He's saying keep your mouth open so you don't explode your eardrums. Yeah, baby. What is this? What is that? You think that's smoke? No, that is not smoke. That is water. That is water. With water vapor. All right, so what did happen? Let's talk about exactly what happened when that gigantic explosion went off. Why? Why? What blew up? Now, this doesn't have a whole lot of relevance, but I'm going to tell you what, it really does to me, because this excites the hell out of kids when they see something as impressive as this. Now, just listen to how they are reacting. Listen to this. Now that's excitement. I love that.
So the difference. So this has to do with reaction kinetics. One was fast, the other one was slow, and the same energy or similar energy was released in a very short time or in a very long time.
All right, what does the short time mean? All right, you saw that experiment. He had H2 and O2, and he added a spark to it. He added it in a balloon. What came out? We saw the water vapor, all that mist. That's water, and that's H2O. So what happened to the other O? The other O turned into the electrons. And in my model, in one single O, which is 16 proton units, basically, it ends up being 29,168 electrons. All went out like that. When an electron takes up its own space, it's huge. When it's in the nuclear condition, it's tight. So what we did was we liberated 29,000 electrons all at once, instantaneously. Now, not only did I show you that, and it just proves what would come out of hydrogen if there was just two big balls. That's it, nothing. Isotopes prove my point as well. What is an isotope? An isotope, it means it's just exactly the same as that molecule, except it has extra electrons or not enough electrons. And they become sort of stable and not stable. So it's like this should have exactly this number. But guess what? There's some of them missing. So it wants some more. Eventually it'll take on another one. And then another one, it'll take on another one. And then they'll take on another one. And then all of a sudden it'll be at its right number, and that's stability. And that's what decay is. Now, neutrons, what are they? They're even numbers. They have the even number of these dipoles. That means it's not charged. There's no charge to this. They're even. So it says, I don't want one. I don't want to give one up. I'm happy. Well, what about a proton? Protons are odd numbers. Now, I believe these are the numbers. I could be wrong. They could be somewhere right, but they're pretty close to this, 1800 and something. I originally had 1800 and, boy, I think 38 or 36 or something. But I think I refined it down to about 1823, 24. Could be wrong. Electrons are only one of these. All of these are made out of that same particle. And that is exactly what it looks like right there. It's a black banger, never changes, and this one can get glowy and small and has all the energy and none of the push. This is all the push and none of the burn. Okay, so we did fission and fusion, but we did it in the photonic range, which is down into this range, which for Fermilab, CERN, they all see these same two particles. One of them is a banger, has no energy value that they can determine, but it's just a slammer, and it's always the same size. It's called a fixed particle. This one glows and gets smaller and it burns like hell, which you will see in a minute. And these are that particle, and these are that particle. Now, one of these together is what I would call an electron, but it has a dark side. We never knew it. That's dark matter, it's gravity, it's all of those things. Together, these two, like they're little bar magnets, they hang into each other and they create a photon. Now, the photon, we actually created fission from that photon and separated the black from the white. And here it is right here at the Venturi. That's fission. Right, the black came away from the white. Here's fusion when it comes back together. Now, what they are doing at the national laboratories is they are creating fusion of two nucleuses. We're creating fission of the actual light particle. Now, totally different, but totally the same. Because they had to create fission before they could get the fusion. When they bombarded that pellet, they made it fission. They created fission, and then they globbed back together and created fusion. But all they did was liberate a ton of electrons, just like we did. We were liberating electrons, but we didn't have to use any excess energy at all, and all we used was a pulsed red laser, and it created fission and fusion. All right, if you just looking at the words fusion and accepting everything they've been talking about, well, you're not going to understand. You're going to keep hearing the names Cherenkov radiation, and you're going to hear muon neutrinos, electron neutrinos, sterile muons, bosons, fermions, all of these different things, Higgs fields. Well, this is a sterile muon, these black ones. It's just exactly what they're saying here. They came in attached together, the black and the white. They separated here, is what we did. We created fission, and the only reason you can see that black ball is because it's obscuring the white. You would never see that black because it doesn't radiate. It doesn't radiate, it doesn't absorb, it doesn't emit, it doesn't do anything. But it's sitting on top of our radiation. So we're the same over here. We can see the black balls. You never see them. Nobody's ever seen them before. And let me take that back. They see them at Fermilab and CERN, and they have no idea where they came from. We see them. Well, let me show you how we see them. All right, here's what happened. The laser's coming in from here. It's a pulse laser. Boom, 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 boom. Well, these are the particles as they begin to stack up. I believe these are what you would call tau neutrinos. They're not into the full phase yet. There's more black than there is white, and they're heavy. Then, for some reason, they turn into the photons, which are two whites and two blacks. Now, whether there's enough white in there to create these two, normally it's sandwiched together, but it's still the same as this, but it has to stack up against itself to push into this configuration, I don't know. But it started like this. It reconfigured to this. This is all the same picture of the same particle, because it's light. It's happening so fast. We're getting them all at once, and I can prove that by showing you the blue. Now, so is that the same particle as here, or has it added something? I don't know. But it's getting sharper and sharper, and the points are going up and down, and it's getting glowier and glowier, and then it explodes. Here is where the explosion occurs, and the white separates from the black. That's fission. After it goes through the Venturi, the white is all by itself. It has to come back to the black, and I can show you that happening as well. All right, this is the event in progress. The original wave is coming through here and is being sucked into the Venturi. So you see it elongate, and then the field collapses because the particle has to go so fast that it's beating out the magnetic wave. So it's accelerating. There's no question that's acceleration, unless you can think of something else. Now, what happens here? It starts to stack up on itself. When it does, it starts to glow like hell, and here it just explodes. When it explodes, what happens? It's literally an explosion. You see these here? Those are being concussed from this explosion. And these magnetic fields back here, you see those? Those are what they call reverse EMF, reversed electromagnetic field. You see how powerful that thing is? That's coming back from that concussive event. I don't see how we could possibly miss getting extra energy from this. And all we did was create a Venturi here, single slit. I can go through all the details of this, and believe me, I have all the details. You see this? Not only can I prove that one shot is all one picture of the same particle, I can show that the blue is so energetic you can't even tell it's got the two little white spots here. Down here you start to see it show, because it's slowing down. That means light can slow down. I showed you light accelerating. Virtually everything that they think about the particle nature or wave nature of light is strictly a magnetic field surrounding a particle. That field's got to get through everybody else's field. That creates a wave. Just so you know, they all have the two whites and the two blacks, and they all spin like crazy, going through the air because the forward-leading white part charges up, and then it flips. And then the reverse one comes in front and starts to absorb all the impact. Now, these, I think, are the same things. I think these are those the tau neutrinos. And then, of course, these are the photons, and then they split. And the black splits too. I mean, the green splits, the blue splits, they all split into their component parts, the black and the white, the muon neutrino, electron neutrino, and electron shower. All right, this is exactly what's happening. Light spins in a circle. And why does it spin in a circle? Because it's got to push its particles against the particles that it's impacting. It's going through the air. But when it goes through the air, it's got to scrub past these, and which forces it to turn into a circle. Right-hand spin is the norm. They call it the right-hand rule. Now, you see this? That's a drill bit. This is a single slit, and we're seeing the separation, which they call the interference patterns, are strictly from pushing the particles away from each other. They hate each other, the white ones. So that's why the ones that glow separate. The black ones you don't see. They're black. They're dark matter. They're dark. You never saw them before. Okay, this is from Don Lincoln from Fermilab. He's seen the two particles. They've all seen them. These are the exact same two particles, smallest particles that exist. This one is a fixed particle, just a slammer, and this one is a glowy particle, and it's a burner. Now, I say these coat everything that is. The dark matter goes to the center. And how can I show that? Well, because of the Russians in space. And I contacted Don Lincoln about this and the Russians at the same time about their experiment. And Don was less than cordial, let me put it that way. All right, this is what the Russians did in space. They put charged particles into a vacuum chamber in zero gravity, and it formed a black hole. And that's what we're seeing all over the place, is these black holes, and they just can't explain it. Well, they keep collecting more and more of the white energy, because the white ones also have black ones attached together. But there's more appears black than there is white. I thought they would be balanced, but I don't think they are. Earth is nothing more than this exact configuration. It sucks all of the charged particles. Any electricity goes right into Earth. We have more dark matter inside Earth than we have glowy particles. Lightning, right to Earth. Static, right to Earth. Electricity, right to Earth. Gravity, pulls everything to Earth. Our core is loaded with dark matter. All right, so we know that the black can separate from the white, and we know that we have these black strips, sort of, in between the white heavier strips. Those are the push to shove, and so I would say that there's probably more dark matter than there is white matter in the universe, possibly. And they collect in these balls, and then everything wants to gravitate towards them as they spin through space. Now, let's look at our situation, because we are on one of these in concussing with everything that's in front of us. So whatever particles are in space, which is saturated, and Fermilab agrees to that, they call it the quantum foam, it's everywhere in space. We're scrubbing through it. So you remember I showed you the particles that they had from Fermilab? They also say the same thing I say. Space is loaded with particles. See, this is again Don Lincoln. Empty space isn't empty. It's saturated, 100% saturated with the foam of these particles given off by the sun, or by all luminous bodies, every one of them. Now here's the heart of the problem. They cannot get off this standard model. You see this? Here's Don Lincoln again. Most successful theory ever. It is not successful. This is successful. W and Z bosons, yes. After that, everything else is just fluff. Everything there is made out of those two particles. 100%. They make up the nucleus, they make up electrons, they make up everything there is. This is actually the most successful theory ever. It covers every single event there is. And I can fit it into their standard model, but all of this stuff is fluff. These are the only two particles that exist. Everything else is made from those two particles. And this is all my evidence. I'm building a case here for this. I understand it pretty well now. And because these are all dipoles. It works for, there's nothing that doesn't work, not a single thing. If you can come up with any single electronic interaction, or, well, let me show you the atomic bomb, and that's going to prove these two particles are exactly what I say they are, and they're exactly what CERN and Fermilab say they are. The muon is just a smasher, never changes size, fixed. This one glows and comes down, and this white will always surround the black. That's what the black hole is. We never knew it was in the side of our protons and protons and molecules. We just never knew it because it doesn't emit. It just attracts. We just never knew it. Light is dark matter. It is. Light is dark matter. And I put the video out about that in 2015. As I was trying to get everybody together on this, I put out light is dark matter in the vacuum of space until it collides with Earth, something like that. But that's all. It's dark matter until it collides. And then that field that surrounds that one little glowy particle, or in this case two, bounces. And when it bounces, if it's a photon, it will bounce. If it's an electron, it'll zip, it'll burn right in. So we've got some thinking to do, but this is going to be the most successful model that's ever existed. All right, most of us probably have seen pictures of a galaxy with spinning. Inside there is where the dark matter is, and all of the white matter is trying to migrate into that because the dark matter is gravity. And at the same time, everything is spinning. You see these arms are pushing back? This is dark matter in between the interference patterns. These are saying, get away from me, you get away from me, you get away from me, you get away from me. That's why we're getting these stripes. Those are interference patterns. But as the more matter collects and these black stripes get pushed into the center, it gets pullier and pullier. It pulls harder and harder. Because that's what gravity is. And the bigger it is, the harder it pulls. And they're saying about that. All right, this is the issue. Coming out of the sun is just a ton of particles. Some of them are complete particles, some of them are half particles, some of them are 10 particles at a time. All kinds of stuff is spewing out of here. Now, it's spewing at us. We have to scrub through it because we're spinning. And the harder and tighter this atmosphere becomes as it swells, the scrubbery it is. It's just the nature of two things scrubbing against each other. This is where we're having all our problems. Terrible tornadoes, terrible floods, terrible hurricanes, terrible drought. All kinds of things happening in this layer that is scrubbing through space. Space is not empty by any means. All right, look at this. They say they have achieved the smallest measurement yet of a ghost particle's mass. These are the neutrinos that are smaller than electrons. They're saying it's 0.8 electron volts. How they determined this, not even understanding that the neutrino is a positive and a negative particle all in one little piece. And they also, I think in here, hold on a second. This is the problem we have. They just don't understand the particles. These are the people doing all this fancy research, and they say that photons have no mass. Besides photons, the massless elementary quanta particles, which are light, neutrinos are the most common particles in the universe. Neutrinos make light. Neutrinos are part of light. I showed that. The neutrinos are part of the light. Now, they just realized that 20 years ago they said they were massless. Well, now they say it's possible to show neutrinos, contrary to earlier expectations, have a very small non-zero mass. Well, photons are non-zero mass, so are muon neutrinos. And electron neutrinos. They all have some mass. It's not very much, especially the electron neutrino. That sucker there is a burner, but it just doesn't seem to move anything. The other one, the muon neutrino, that's a slammer, and it never changes size. One size fits all. Green, red, blue, doesn't matter. All right, so I've been reading as much as I can about this. And this is the article about neutrino mass measurement with sub-electron volt sensitivity. Since the discovery of neutron oscillations, which is they're rolling basically, we know that neutrinos have non-zero mass. However, the absolute neutrino mass scale remains unknown, and they're never going to figure it because there is no mass to a neutrino until it interacts with something else. Mass is a function of pushing and shoving. Now, it may have some rest mass that I don't know if they'll ever be able to calculate because it's so small. Even when it's hitting from a nuclear bomb, it has almost no push to it. It's moving. We know it's moving because it went from the nuclear bomb out to the house, and we saw it burn the house, but it just didn't seem to push the house much, if at all. Very, very small amount of interaction other than the burn. But when that black one came, boy, it was all interaction and no burn. Now, this is my email. It's roger@mudfossils.com. This is why most of them don't want to talk to me. I get called a tinfoil hat guy because of my research into ancient fossils and so forth, which is 100% valid as well. That is a goose head. There's his feathers, the pattern of the feathers in his head. I have understood this 100% fully. It's nucleophilic substitution, and it creates feldspar when it interacts with the aluminum silicates and collagens. Bones turn into stones. I have so much on this. I have DNA tests and CAT scans and everything. So don't look me up and say Mud Fossils, the guy's an idiot. I understand this stuff as well as anybody on the planet, and I know more about rocks and mud fossils and ancient everything than anybody else on the planet. So I deserve a chance to be spoken about, or I deserve a chance to speak. I don't care if they speak about me. They've been speaking about me a lot, saying that I'm an idiot, I think, mostly. But what I'm showing shows that I'm not the idiot.